So my name is Olexii Padun. I'm a chief design engineer, and that's a project of science and space company called Space Islands, the way to save humanity. Humanity is growing, and in the nearest future, it will be required to leave our beautiful blue spot, planet Earth, to continue our existence in space. Our space islands will be located between orbits of Earth and Mars. But before that, the testing smaller island for 100 person will be placed in the Lagrange L4 or L5 points in the Moon-Earth system. And the project mission of the island is to deploy it in the Lagrange system as the most stable point in the Earth-Moon system to save the energy of orbital maneuvers and stabilization. It will have magnetic field to secure safety from the dangerous solar wind, and it will have ozone layer to secure safety from the dangerous ultraviolet rays from the sun. The problem of artificial gravity is also solved on the island with a system of magnets located in the living zone, which will provide the force which will simulate gravity in the living areas of the island. And there is an infrastructure to make the island as independent from the Earth as possible. The space island is an extremely complex engineering system, which includes several subsystems which will use the modernist technology of its time. The main systems are electrical, life support, recycle and renewment, artificial magnetic field, and gravitational systems. On this slide, you can see main specification of this smaller testing island to be located in Lagrange points. And this slide shows the magnetic field, as you saw it in the one of the previous presentations. It will secure the safety from the solar burst, and it is created by the big coil with a diameter of 6.4 meters in the middle of the island. The system creates magnetic field, which equals the Earth's magnetic field in terms of magnitude and the direction. And it solves not only the radiation problem, but also the biological one with the right magnetic background for organisms. Artificial gravitation. The island will have artificial gravitation, which will simulate the dragging force to the floor. And it will be comfortable to live in. It will be as comfortable to work as on Earth. It works because of the interface of the space closes and the magnets located underneath the floor. It is also simulated by doing the finite elements method, and you can see the main characteristics of this system on the slide. Water circulation. The island will have water circulation and cleaning system, which was calculated for one person, and it is also pressurized and cleaned every time. This whole system is powered completely from the solar panel or from the backup power units, which are methane engines. Electrical system. The system uses 20 electron systems for atmosphere purposes, and it has pretty big solar panels with area of 80,000 square meters and mass of 630 tons, which produce a power of 30 kilowatts. But also it has backup power units, which could be used in emergency cases or where more power is needed. The space island is divided in several areas where people will live and work. It is a living area, relax area, scientific area, garden, and medical area. So the island is a city in space. Location of the island. The location of the island is Lagrange points L4 or L5, as it was mentioned before, Why we have chosen this place? Because it's the most stable part of the nearest space from the Earth. You don't need energy to stabilize it because even smallest derivations from this point will take the island back to the Lagrange points. So this location was chosen for our 20-meter diameter smaller testing island. Orbital maneuver to get to the Lagrange point is a Hohmann transfer. It is a flight-proven maneuver, which is the most energy-efficient way to fly there. It is done through 2 engine starts, and it is completed in 123 hours. Here's some details about flight procedure when we're doing this orbital maneuver to get to the Lagrange point. And if you're launching with a vehicle with refueling on orbit, so the one rocket starts filled completely with fuel, and the second rocket starts with payload. On the lowest orbit, they dock each other, they start refueling procedure, and then this 100 tons rocket launches to the Lagrange point. If this procedure would be implemented, it would take 118 launches to complete the space island in L4 or L5 points. Space island atmosphere. On the island, you can breathe as easy as on planet Earth, so air conditioning and cleaning system is powered from solar panels to provide proper composition, humidity, and pressure on the island. And future islands will become more and more independent by implementing the system of this interconnection between different islands. There would be delivery from asteroids and comets for mining resources, water from them. The more and more flora will be synthesized on the island, and the extraction of water from comets will be conducted as well. And these resources can be used even to build new islands and to create a system between Earth and Mars. Nutrition. The island is using the modernized technologies of food production and synthesis. So the food of plant origin will be grown on the island, while other sources of protein could be synthesized on the island, which could also be powered completely from the solar panels from electrical system presented above. Breeding. The island will use Ukrainian experiments a lot. As we know, we have conducted, Leonid Kadeniuk has conducted several experiments on board of the space shuttle. The results of those experiments could be used on our island, as well as international researchers from NASA and other space agencies. That's very important for mental health of the people on the island. So plants will be grown, and it will cause a positive effect on psychological health of the crew. Recycle. One of the key points of the island is to make it as independent as possible. So recycling will be implemented as well, and it is powered from solar panels as well. But not recycled waste will be sent to a heliocentric orbit in future to take it back to safely collect and dispose. And hydrogen released from the oxygen production process can be used as fuel for incoming spacecraft. Excess could be drained or used for deorientation purposes. As a conclusion, along a theoretical physicist and mathematical solve the equations of the achievable universe, humanity can and should master the middle and far space for its residence, organization, or production, or rest, or therapy. This is a question of human survival, because as Stephen Hawking said, the death of planet Earth is only a matter of time. So we can do something, and we are doing something. We are moving to space. The presentation includes innovation coefficients in its calculations as a perspective parameters. Those coefficients are calculated based on current tendencies of modern technologies in the perspective of 5-7 years. Because as we all know, when the terrestrial technologies is used in space, it becomes far more advanced. So those coefficients are calculated based on those trends, and the law of accelerated development on science, technology, and social relations. You can see the coefficients which were used on this slide. Thank you for your attention.